Hello students, these are the topic tests that we at Bodhee Prep have prepared for you to help you gauge your level of preparedness for a topic. So the idea is you do the basic concepts of the topic and basic practice, and then take the test to understand whether that concepts or those concepts that you've picked up, you're able to apply that in a new test format or not, in a timed way or not. Once you give a test, there is a video with every test which explains the solutions, and we give you a perspective of what could be a good attempt for that kind of a test in terms of the level of difficulty, the time that you should have taken. And the best part is more than 200 topic tests are available on the Bodhee Prep Android app. So the link for the app is in the description below. Feel free to download the app and make use of these tests and then get cracking with your preparation. This video is about the covers questions on factorial, cyclicity, and base system, and this is the fifth test of these topics in the app. Overall level of difficulty for this test would be about moderate. 6 to 7 questions net correct would be a good attempt for this test. That would fetch you probably a 95 percentile plus in a similar sort of a exam, the actual CAT. And in terms of uh, time required to attempt this test, the time should be somewhere between 18 to 21 minutes. So it is pretty much a replica of what you would be doing in CAT. In the real CAT, you have about 22 questions and 40 minutes to attempt. Here there are 10 questions, so 18 to 21 minutes should be good enough to go through all the 10 questions, find the easier 7 questions and get them correct. Looking at the question, the first question says the number of zeros present at the end of 100 factorial. Now, this is a very straightforward question. Uh, zeros means the number of times 10 divides 100 factorial, and 10 is 2 into 5. 2 will not be the limiting factor, there will be fewer 5s. So we simply see the highest power of 5 dividing 100 factorial. And for that, all we have to do is we keep successively dividing 100 by 5. 100 by 5 is 20, 20 by 5 is 4. So the highest power of 5 in 100 factorial is 24, and therefore the highest power of 10 in 100 factorial will be 24, and therefore it will have 24 zeros. Now, if you've done factorials, this is one of the first questions that we cover, trailing zeros, and therefore this should be a pretty easy question, not more than a minute in any case to answer this question. N is equal to 70 factorial into 69 factorial into 68 factorial and so on. Which of the following represents the 147th digit from the right end? If we write the product from the end, we are looking at the 147th digit. Clearly, this number will have a lot of zeros. So let us first try to count the zeros. The number of zeros at the end of 70 factorial. So basically, we'll divide this by 5. And the highest power of 5 that divides 70 factorial will be the number of zeros at the end of 70 factorial. 70 by 5 is 14. 14 by 5 is 2. So 16. 70 factorial has 16 zeros in the end. 69 factorial will have one less than that, because 69 and 70 differ in the sense that 70 has one extra multiple of 5. 68 factorial will have the same number as 69 factorial because there is no extra 5 here. 67 will have the same. 66 will have the same. 6, 7, 8, 9. 65 factorial will have the same number of zeros. If you look at 64 factorial now, 64 factorial will have 1 5 less than 65. Because 65 factorial is 65 into 64. The number of zeros of 64 multiplied by the 5 from 65 will increase the number of 0. So here there will be 14. 63 factorial will have 14. 62 factorial will have 14. 61 factorial will have 14. 60 factorial will also have 14. Then, if you look at 59 factorial, this will be 1 less than 14, that is 13 zeros. 58 factorial, again 13 zeros. 57 factorial, again 13 zeros. 56 factorial, again 13 zeros. 55 factorial, again 13 zeros. Now, if I simply add this, I'm getting 1, 2, 3, 4, 5. 75 plus 6, 81. 1, 2, 3, 4, 5. 70. 165. So basically, in the last 6 numbers, there are 81 zeros. This gets multiplied with a number in the next 5, we have 70 zeros. So if we multiply this clearly, the last 151 digits definitely will be zeros. Obviously, there will be a lot more zeros than 151, but we can be sure that the last 151, just from here, digits will be 0, and therefore the 147th digit from the last will also be 0. The number of zeros in the end will be a much larger number, but for now, 147 will definitely be a 0. I've just checked from the extreme end, and checking for the first 10 number make sure that I cross 147. Now, in terms of level of difficulty, I'd say moderate, because figuring it out might take some time. But once you start looking at the first couple of digits or the numbers, you should realize that there is a pattern which can be followed. Hence, I'm saying moderate level of difficulty, but solving time should not be more than about 1.5 to 2 minutes. If the sum of the number of zeros at the end of factorial of each of the first n natural numbers is 250. The factorial of how many of these natural numbers will end with an odd number of zeros. So let us take the value of n as 5. 1 factorial, 2 factorial, 3 factorial, 4 factorial, and 5 factorial. What is the sum of the number of zeros at the end of each of these numbers? 1, 2, 3, 4 have zero zeros in the end. 5 factorial has 1 0 in the end. The sum of the number of zeros for 1 to 5 or n is equal to 5 will be 1. Similarly, if I look at 6 factorial, there is the number of zeros is 1. The sum will now become 2. 7 factorial has 1 0, 8 factorial has 1 0, 9 factorial has 1 ending 0. So the sum till this point will be 5. The moment we reach a multiple of 5, the number of zeros increases. So 10 factorial has 2 zeros. This goes on till 14 factorial. So the sum of the zeros for 10 to 14 will be 10, 11, 12, 13, 14. 5 numbers having 2 zeros, so 5 to the 10. Similarly, from 15 factorial, number of zeros will be 3. This will go until 19 factorial. So we'll have 15 zeros. From 20 factorial, the number of zeros will become 4. It will be so for each of the numbers from 20 to 24. The number of zeros becomes 20. 5 fours are 20. In the end of the sum of zeros in the end of 20 factorial to 24 factorial. 25 factorial is a multiple of 25, so there are two 5s. So as we go from 24 factorial to 25 factorial, we multiply 2 extra 5s. So number of zeros will increase by 2 and become 6. Rather than 1, here the increase will be 2. This will go until 29 factorial. So the number of zeros total added here is 30. From 30 factorial to 34 factorial, again the increase will be by 1. So 7 zeros each, 35. From 35 factorial to 39 factorial, the number of zeros will be 8 each. This will add up to 40. From 40 factorial to 44 factorial, the number of zeros will be 9 each. And therefore 45 zeros added. Just to get an idea of how many zeros are there till now, 5 plus 10, 15, 15 plus 15, 30, 30 plus 20, 50, 50 plus 30, 80, 80 plus 35 is 115, 115 plus 40 is 155 plus 45 is 200. So we have 200 zeros till this point. The moment we go to 45 factorial, we will have 10 zeros in the end. This will go on to 49 factorial. So 50 more zeros added. So when n is equal to 49, we see that the total sum of zeros at the end of the factorial of each of the numbers becomes 250. How many of these natural numbers will end with odd number of zeros? We can see that these 5 numbers have 1 0 in the end. These 5 numbers have 3 zeros in the end. These 5 numbers have 7 zeros in the end, and these 5 numbers have 9 zeros in the end. So 5 plus 5 plus 5 plus 5. 20 natural numbers will end up with odd zeros in the end amongst these values. Now, this I'd say is a moderate to difficult level of question. My solution here is one of the most rudimentary solutions. I've outrightly counted the number of zeros and added. Yes, not a very efficient way of solving, but what I'm saying is the answer will be there. 2.5 to 3 minutes, depending on how easily you're able to see the pattern and whether the increase in the number of zeros at multiples of 5 and multiples of 25 is clear, will determine how much time we take. But easily 2.5 to 3 minutes to solve the question. I'd say moderate to difficult level of question. This one, as far as factorials is concerned. What is the unit digit of 7 raised to power 14 raised to power 21 plus 4 raised to power 15 raised to power 25? Now, if you look at this number here, This is 7 raised to power 14 raised to power 21. 14 raised to power 21 when divided by 4 will give us a remainder of 0. Even number raised to any power other than 1 becomes divisible by 4. So this is equivalent to writing 7 raised to power 4 for unit digit. 7 raised to power 4 unit digit is 7, 49, 31. 61. So the unit digit from here will be 1. Plus, if you look at this, 4 raised to power 15 raised to power 25. This is essentially 4 raised to power odd. 4 raised to power odd ends in 1. It ends in 4. Because the cyclicity of 4 is 4, 6, 4, 6. So this will always end in 4. And the unit digit will be 1 plus 4, which is 5. Option B becomes the answer. Again, not a very difficult question. Also a concept that we did in class. So I'd say the question might look a little daunting. So I'm saying moderate level of difficulty, but definitely a question that should be finished off in less than maybe a minute and a half. 677 is exactly 5 digits and converted into base n. So 677 is a decimal number. We are converting into base n has exactly 5 digits. 1, 2, 3, 4, 5. From the decimal, so what is the minimum possible value of n? Now, if you look at the options are 3, 4, 5, 6. So let us look at the maximum 5-digit number in base 3. This will be 2, 2, 2, 2, 2. In terms of decimal, this will be 3 raised to power 0, 3 raised to power 1, 3 raised to power 2, 3 raised to power 3, 3 raised to power 4. Powers 0, 1, 2, 3, 4. Each gets multiplied by 2. Plus into plus into plus into. This is nothing but 2 into 3 raised to power 481 plus 27 plus 9 plus 3 plus 1. This is 9 plus 1, 10. 27 plus 3, 30. 30 plus 10, 40. 40 plus 80, 121. So 2 into 121, which is 242. Kind of makes sense. Because if you look at the 6-digit number, 1, 2, 3, 4, 5, 6. The smallest 6-digit number in base 3 would have a value 3 raised to power 0, 1, 2, 3, 4, 5. The value will be 3 raised to power 5, which is 243. So a number less than that has to have a maximum value of 242. So 5-digit number in base 3 cannot reach 677. If you look at base 4, 1, 2, 3, 4, 5, base 4, the smallest value will be 1, 0, 0, 0, 0. 1, 2, 4 raised to power 0, 1, 2, 3, 4, which is 4 raised to power 4, which is 4, 4, 16, 64, 256. And a 6-digit number 1, 2, 3, 4, 5, 6 in base 4 will have a minimum value of 4 raised to power 5, 4 raised to power 0, 4 raised to power 1, 4 raised to power 2, 3, 4, 5, which is 1024. Clearly, 5-digit numbers in base 4 lie between 256 and 1024. 6677 is in this range. So the minimum value that n can take is 4. In base 4, I'll be able to convert 677 into a 5-digit number in that base. Hence, 4 becomes my answer. Just looking at the range of numbers in that base, starting from 3 going up to 4, since the options are 3, 4, 5, and 6, gives me the answer as 4. Again, in terms of the approach, I would say a moderate question, but even in the worst case scenario, if we start converting 677 into base 3 and then base 4, we will still get the answer and should not take more than about 2 odd minutes maximum to get this question done. What is the sum of the last 2 digits of? Now 7 raised to power 5296. The good thing with 7 specifically is 7 squared is 49, 7 cube is 343. 7 raised to power 4 is 2401. And therefore, if you look at the last 2 digits of 7 powers, they will be 7, 49, 4301. And the moment we get 1, we multiply 7, we'll get this again. Therefore, the 2-digit cyclicity for 7 is also of 4. Now 7 raised to power 5296 is a multiple of 4. 96 is a multiple of 4. The last 2 digits of 7 raised to power 5296 will be the same as the last 2 digits of 7 raised to power 4, which is 0, 1. So we get 0, 1 here, plus 3 here, and therefore the last two digits will simply be 0, 4. Now, this is a pretty straightforward question. What is the sum of the last two digits? So the sum will be not 0, 4, but 0 plus 4, which is 4 becomes the answer. Straightforward question, especially because the last two digits that are to be calculated are for 7, which has a smallest cyclicity that is possible. Hence, I'm saying easy question, 90 odd seconds to get the question done. BCD is a number format that computers sometimes use. In BCD. Base 10 digits are encoded into groups of 4. So 0 to the base 10 will be 0, 0, 0, 0, 1, 10 will binary 0, 0, 0, 1 and so on. 1, 2, 4, 8, 8 plus 1, 9. For example, if I have to write the number base 10 number 47 BCD, first we'll convert 4 into a 4-digit binary, which will be 1, 0, 1, 0, 0. And then we'll write the binary for 7, which is 0, 1, 1, 1. That becomes 47. Given this, let A be the sum of digits of 2, 4, 8, 6, 7 written in binary in BCD. So if we write BCD of 2, 4, 8, 6, 7, we have to write 4 digits. 2 will be 0, 0, 1, 0, 2. 4 will be 0, 1, 0, 0, 4. 8 will be 1, 0, 0, 0. 6 will be 4 plus 2, 0, 1, 1, 0. 7 will be 0, 1, 1, 1. The sum of digits here is 1, 2, 3, 4, 5, 6, 7, 8. 2, 4, 8 are powers of 2, so the digit will be 1. 6 requires 4 and 2, so the sum will be 2. 7 requires 4, 2 and 1, sum will be 3. And therefore, 1 plus 1, 6. 3 plus 2, 5 plus 3, 8 becomes the sum. Now we are looking at the binary of, let B be the sum of the digits of 2, 4, 8, 6, 7 written in binary. So when we look at binary, 2, 4, 8, 6, 7. I'm looking at powers of 2. The powers of 2 will be 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 2 raised to power 4, and so on. Two raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 2 raised to power 4, 2 raised to power 5, 2 raised to power 6, 2 raised to power 7, 2 raised to power 8, 2 raised to power 9, 10, 11, 12. A little difficult to write. Rather than horizontal, let me write it vertical, probably would be easier to do. So I am writing the numbers in the vertical from the last digit. So the digits will be 1, 2, 4. The power of 2 multiplied will be 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096, 8192, 16384. Beyond this, it will cross 16,000 or it will cross 24,000, it will become 32,000, so not needed. Now I start putting values here for binary. Obviously, here the value will be 1. So from 24867, 24867, 16384 has been used. This is 3 plus 816. This will be 8, 4, and 8. It will be 8483. For 8483, I cannot use 8192, we use 4096. So from here we subtract 4096. This becomes 8192 could also have been used. It is less than that, sir. We can use 8192 here first. So 8192 becomes 1. 8192 subtracted from 8483. This will give us 19918 to 291. So this becomes 0, this becomes 0, this becomes 0, this becomes 0. Then 256 becomes 1 minus 256. This will be left with 35. Becomes 0, becomes 0. 32 becomes 1. 32 will be left with 3. So for that, this becomes 0, this becomes 0, this becomes 0. 2 becomes 1 and 1 becomes 1. 2, 4, 8, 16, 32. Extra 0. 1, 2, 4, 8, 16. 32, 64, 128, 256, 52, 2. And therefore the binary form of this will be 1, 1, 0, 0, 0, 0. 1, 1, 0, 0, 0, 0. 1, 0, 0, 1. 0, 0, 1, 1. 0, 0, 1, 1. This will be the binary of the number. If you look at the number of ones used, 1, 2, 3, 4, 5, 6 ones are used. So some of the digits here will be 6. First case, the value of A was 8. The value of B is 6. Calculate A plus B. A plus B will be 14. Now, I'm calling this a moderate level of difficulty question because converting to binary might take some time. Apart from that, in terms of concept, not very difficult to solve per se, and therefore overall level of difficulty moderate. Time to solve about 2 to 2.5 minutes. In what base is the following equation true? 123 in some base, say n, into 321 in some base, say n, multiplied gives us 39383 in that base. Clearly the base has to be more than 9. Base could be 10, 11, 12, 13 and so on. If we multiply 3 ones are 3 will be a valid number in that base. 1 twos are 2, 1 ones are 1. Multiplied by 2 it will give us 2, 4, 6. Again all the digits are valid in that base. Multiplied by 3 will give us 3. It was 3, 6, 9. Again all the numbers are valid in that base. 3 remains 3. 6 plus 2 is 8. Not a problem. Now in decimal system 9 plus 4 plus 1 should be 14. But according to the question, the digit here is 3. So instead of 13, the value in this base, instead of 14 of decimal, the value in this base is only 13. So we can say 14 is equal to n plus 3. N into 1, n raised to power 1 into 1 plus 3 plus n 3 into n raised to power 0. The decimal equivalent of this will be n plus 3, which gives us n as 11. So the base is likely 11. So 14 becomes 13, carry forward 1, 6 plus 2, 8 plus 1, 9, 3 as it is, the same number that we are getting in the answer. So the base is simply 11 here, and that is my answer. If I wanted to convert it otherwise, it would have taken a little more time. So I'm just making the conversion during the multiplication. In terms of level of difficulty, I'd say moderate. Figuring it out might take a little time, but the number of steps involved is minimum. We just have to look at one digit, and from there the question happens. So the solve time should not be very high ideally. Even if we decide, if this is something that you're not comfortable with, and you decide to solve this question with all the steps, we will write the decimal equivalent of all the numbers and write the equation. So this will become n square plus 2n plus 3 in decimal multiplied by 3n square plus 2n plus 1. Here we'll have n raised to power 0, 1, 2, 3, 4. So 3n4 plus 9n cube plus 3n square plus 8n plus 3. The basic method of converting a number in base 10 to a decimal. Multiply these two values or open the bracket, we'll get 3n raised to power 4 plus 2n cube plus n square. Then multiplying 2n, we'll get 6n cube plus 4n square plus 2n. Multiplying 3, we'll get 9n square, 13, 14. plus 6n plus 3. So if we add these terms, we get 3n4 plus 8n cube plus 9, 4, 13, 14n squared plus 8n plus 3 is equal to this term 3n4 plus 9n cube plus 3n square plus 8n plus 3. As you can see, 3, 8n and 3 and 4 will get cancelled. So we'll get 3 comes here, 11n square is equal to n cube. Dividing away n square, we'll get n is 11. Even if we are doing this entire process, should not take more than 2 minutes. But this is an easier approach, basically. When written in base 12, how many zeros does 2021 factorial end with? Now, this is a standard format. We just have to see how many times 12 is able to divide 2021 factorial. The number of times the division happens, we'll get the remainder as 0 in the end. 12 is nothing but 2 square into 3. So basically, we are checking for the highest power of 2 square and 3 that divides 2021 factorial. If we look at 3, 2021 divided by 3 would be 6 3s are 18, 6 7s are 21, 3. 673 then divide 673 then divided by 3 would be 3 2s are 6, 3 2s are 6, 1 224. 224 divided by 3, 224 divided by 3 will be 7 3s are 21, 1 4, 7 4s are 12. 74 divided by 3 will be 24. 24 divided by 3 would be 8. 8 divided by 3 would be 2. And that's it. So if we add these, 673 plus 224 will be 897. 897 plus 74. 8973. 971. 971 plus 24 will be 925 plus 10. 9 plus the count. 897. 897 plus 74. 3 goes here. 971, 995, 995, and 1005. So 2021 factorial has the power of 3 as 1005. If you look at the power of 2 now, we are starting with 2021. 2021 divided by 2 will be 1010. 1010 divided by 2 will be 505. 1010,000. 505 divided by 2 then will be 252. Greatest integer function. 252 by 2 will be 252. 126. 126 by 2 will be 63. 63 by 2 will be 31. 31 by 2 will be 15. 31 by 2 will be 15. 15 by 2 will be 7. 7 by 2 will be 3. 3 by 2 will be 1. The highest power is 1010 plus 505, which is 1515. 1515 plus 252 and 126. 378. This becomes 319 1893. 1893 plus 63 and 31 is 94. 1987. 1987 plus 15 plus 7 plus 10. 25 and 227. This will be 2014. And therefore the power of 2 is 2 raised to power 2014. Now if we have to divide 2021 factorial by 12, we will have 2 squared raised to power 1007 into 3 raised to power 1005. Then there will be other numbers as well, but they are immaterial because we are dividing by 12. So we are looking at 2 square and 3 only. Suppose the power of 12 is n. We have 2 square raised to power n into 3 raised to power n. Clearly, n according to 2 square can take a value 1007, but according to 3 it can only be 5. So the maximum value that n can take is 1005. So if we start dividing 2021 factorial by 12, the division will happen 1005 times, and that will be the number of zeros that we'll have in the end when we write the number in base 12. Again, process-wise, it is a repeated process. The calculation might take a bit of time. And since the numbers are close, there is a good chance or there is a very high chance of a mistake happening. So I'm saying moderate. But solving time should not exceed maybe 2 to 2.5 minutes. Which of the following integers in base 7 is divisible by 8? Now, if I write a number in base 7, for example, the first one, 1, 2, 3, 4, 5, 6, 7. It has 7 digits. 1, 2, 3, 4, 5, 6, 7. This will be 7 raised to power 0. This will have a value 7 raised to power 1, 7 raised to power 2, 7 raised to power 3, 7 raised to power 4, 7 raised to power 5, and 7 raised to power 6. Now, if we divide these numbers by 7 alone, 7 raised to power even by 8 will give me a remainder of 7 is 8 minus 1, 8 minus 1 upon 8. So minus 1 raised to power even or a remainder of 1. So from here, the remainders will be 1. When it is 7 raised to power odd, this will be 8 minus 1 raised to power odd. The remainder would be minus 1. If there is a number multiplied, 1 or minus will accordingly get multiplied to these numbers. 1314, 335. So basically what I am saying is, the remainder here will be plus 5, minus 3, plus 3, minus 4, plus 1, minus 3, plus 1. If we add these numbers, 1 plus 1, 2, plus 3, 5, plus 5, 10, minus 3, minus 4, 7, minus the remainder is 0. For the next number, we will have plus 5, minus 3, plus 2, minus 0, plus 5, minus 6, plus 3. The remainder will be 3 plus 5, 8, plus 2, 10, plus 5, 15, minus 9, which is 6. 15 minus 9 is 6. So when we divide this number by 8, we will get the remainder as 6. For the next number, the digits are 1, 0, 5, 8, 2, 4, 1, 4. 1, 2, 3, 4, 7. And the signs will be positive, negative, positive, negative, positive, negative, positive, negative. So 4 plus 4, 8 plus 8, 16. 16 plus 0 minus 1, 5, 6, 7, 8, 9. 16 minus 9 is 7. So the remainder will be 7 when divided by 8. For the last number, 1, 1, 2, 3, 2, 4, 6, 4. Signs being positive, negative, positive, negative, positive, negative, positive, negative. 4 plus 4, 8 plus 3, 11 plus 4, 12 minus 1, 2, 3, 4, 5, 11. 12 minus 11 is 1. So as we can see, the remainder is 0 only in the first case. Therefore, this will be divisible by 8. The idea is every power of 7 as it increases, the remainder goes from 1 to minus 1. And since when we convert this number into decimal, we will have this number multiplied to the power, corresponding power, the remainder will get multiplied to the number. So right now, this can be extended to any base. If there is a number in base n and we are dividing by n plus 1 and we are looking at the remainder, just write the digits of the number and start with the end with a positive sign and put positive negative signs alternatively. Add the numbers, we'll get the remainder when the number is divided by n plus 1. Again, in terms of level of difficulty, I'd say definitely a moderate level of difficulty, if not very high level of difficulty, and 2.5 to 3 minutes easily required to crack the question. So if you look at the overall test, I said initially moderate level of difficulty, 7 odd questions for a 95 percentile net correct, 18 to 21 minutes of attempt time. For me, my 7 questions will be 1, 2, 4, 5, 6, 8, 9. Which are these? This is one of the easiest questions that you can be asked in an examination. Would be doing this because I was not checking for the entire thing. The first 5, 6, or maybe 10 to 12 numbers, if we figure out, we realize it crosses 147 easily, and therefore doing this because not the entire calculation was not required, frankly. This is a question that might not happen in the exam because again I counted all the zeros individually, so can become a little time consuming in the exam, and can create fatigue and panic as well. Would have done this standard repeat question. Would have done this as well. Converting 677 into the different bases will also give us the answers. So definitely an exam question. This is a cyclicity of 7, which if you have done cyclicity would definitely come across. So doing this always. This question again you can take a call on because 24867 in binary could be a little taxing to convert. So can be taken a call on. Would have done this even if I convert the number into base n and then multiply. Even then we are getting a simple equation which was not difficult to solve. So yes, should have been attempted. A repeat process should have been done. Here you can take a call. If you know what to do, it will be easier. Figuring it out in the exam might be a little difficult. Definitely not the easier of the seven or the easiest 7 questions for me. So my pick will be 1, 2, 4, 5, 6, 8, and 9 for this test.